Factor by grouping. Factoring means to write an expression as a product of some factors, and factoring is the opposite of multiplying polynomials. In some cases, there's not a GCF, or greatest common factor, for all the terms in a polynomial. If you have 4 terms with no greatest common factor, then you should think about trying factor by grouping. And it works like we're saying, you need to have 4 terms, and you use this after you've already factored out any greatest common factor for all 4 terms. And when you're stuck with just 4 terms and no more greatest common factor, then you go to factor by grouping. So factoring polynomials is necessary for simpling rational expressions and for solving equations, especially for finding zeros of quadratics. So the first thing, we want to group the first 2 terms together and the last 2 terms together in our 4 terms, and that's the grouping part. And then we factor out a greatest common factor from each of those 2 pairs of terms, and then we hope to have a common greatest common factor between them at that point, which we would factor out. Let's take a look at how that works. So we have x cubed minus 7x squared plus 2x minus 14. And when I look, this has a 1 for its lead coefficient, and so I know there's no number greatest common factor. And then I can also see this term doesn't have an x, so there's no greatest common factor for all 4 terms. So what I want to do is group them, group the first 2 terms together, and then group the last 2 terms together. And I put little trays under them so that I don't lose track and start thinking that I'm actually multiplying them or anything crazy like that. So looking at the first 2 terms, I want to find a greatest common factor. So I'm looking, there's no number again because there's a 1 here, but I do see that they both have x's now, and the lowest exponent is x squared. So x squared will be my greatest common factor for those 2 terms. And when I divide both terms by x squared, I'll be left with x minus 7. And you can also think x times what gives you x cubed. X squared times x gives you x cubed. X squared times negative 7 gives you negative 7x squared. So that one I just double checked. Look at the second pair here, the second group, and I'm looking what can I factor out, and they both have numbers, so I'm thinking 2 because they're both even, and it'll be a positive 2, so I make sure to put that plus down, plus 2, and there's no variable because for my greatest common factor, because 17 doesn't have or 14 doesn't have a variable with it. So 2 is the best I can do. So 2 times what will give me 2x? Well, it's x. And then 2 times what will give me negative 14? And that's going to be a negative 7. Now here's the tough part. This binomial and this binomial have to match exactly for you to carry out the next step. If they don't, you probably did something wrong when you're finding your greatest common factor, like maybe it wasn't big enough, or maybe there's a greatest common factor for the whole problem, or maybe you need to switch the order of your middle 2 terms and try again. So those are the options if you don't come up with a match for your 2 binomials in the next step. So ours match, which is handy, because then what we can do is use that as our greatest common factor. So we have x minus 7 as our greatest common factor. And then we're asking x minus 7 times what is going to give me this first term, the x squared times the quantity x minus 7. And we can see it's just an x squared. And then what are we going to have to multiply that x minus 7 by to get the second term, which is positive 2 times the quantity x minus 7. And the answer, of course, is a positive 2. Now remember, this would be our most factored form because I can't factor this x squared plus 2 any further because it's the sum of squares, and those are not factorable by our current methods. Now I do want to check. So to do my check, here's what I will have to do. X minus 7 times the quantity x squared plus 2. And I will have to distribute the x, and then I will need to distribute the negative 7. Let's try distributing the x. So x times x squared, that's 3 x's being multiplied, so that's x cubed. X times positive 2, that'll be a 2x. And then another color so we can do the negative 7 distribution. So it'll be negative 7x squared and then negative 14. Now when I compare my terms that I came up with here to my original problem, I see that I have negative 7x squared out of order, but I do have a negative 7x squared here. And the positive 2x and the positive 2x here. And the rest of it matches exactly. And so what I'm going to tell you is you can have your terms in any order as long as the sign in front of the term matches from one problem to the other. And I can see it was negative 7x squared, negative 7x squared. So it's a perfect fit. So that's our correct factorization in the box. Number 2, a cubed minus 2a squared plus 5a minus 10. So I want to try factor by grouping, but first I want to look for a greatest common factor. And I'm looking on every term. This one has a 1 for its lead coefficient, so I know there can't be a greatest common factor of a number. And then I look on the last term and there's no variables, so I know there can't be a greatest common factor of a variable for the whole problem. So no greatest common factor for the whole problem. So then I will go to factor by grouping. And to do that, I'm grouping the first two together and then the next two together. And I'm looking on those first two terms, what is a greatest common factor for them? And I see I have a's on both, and a squared is my smallest exponent, so a squared is my greatest common factor. There's no number part because the first term doesn't have a coefficient other than 1, so there won't be a number for a greatest common factor. So a squared times what will give me a cubed? So I have 2 of the a's here. I need 1 more here to get 3 a's being multiplied. So that's an a. And then a squared times what gives me negative 2a squared. So negative 2 goes there. When I distribute, that'll give me a cubed, and then a squared times negative 2, negative 2a squared. So that one works. Look at the second pair, and I have positive 5a minus 10, and I think they're both divisible by 5, but there's no a on the second term, so I know I can't have a variable in my greatest common factor, so it's just going to be a positive 5 times what? So I'm thinking positive 5 times what gives me positive 5a, and the answer is just an a. And then positive 5 times what will give me negative 10, so positive 5 times negative 2 will give me a negative 10. And now I look to see, do I have matching binomials that I can factor out? And I do. A minus 2 is the same on both, so I'm factoring that out. A minus 2. And then I'm asking, a minus 2 times what will give me that whole term here? And that will be times a squared. And then one more time I have to ask, a minus 2 times what will give me this plus 5 times the quantity a minus 2, and the answer is plus 5. So there's my factored form of this polynomial. I do want to check it. So I have a minus 2, a squared minus 5. And let's try it out. Distribute the a. So I'll end up with a times a squared. So I have 1a times 2 more a's. That's going to be a cubed. A times negative 5, so negative 5a. And then I need my blue pen, I think. Negative 2 distributed here is going to be negative 2a squared. And then negative 2 times negative 5 will be a positive 10. And it looks like I wrote my problem to check incorrectly. This should have been a plus. And then when I do that as a plus, we'll recalculate that. Recalculate, so negative 2 times positive 5, that will give me a negative 10, which looks a little better. So I have a cubed, that's up here, negative 2a squared, that's right here, out of order, but the sign is with it, so we're good. Positive 5a, oh, that's where I made a mistake again, because a times positive 5, so that should have been plus. So there's my positive 5a, and then negative 10 at the end, so negative 10. So as you can see, you could make a mistake when you're checking your answer, so always verify that you actually wrote it down properly too. So that one does check out, because I did, once I fixed my mistake in my check, I was able to come up with the exact same polynomial that we were starting with to factor.